8.4. A rational expression is in simplest form if its numerator and denominator have no common factors other than plus or minus 1. Let's pause here a moment. When you are reading mathematics, you do not read it the same way you read a novel or a poem. When you're reading technical material, you need to be pausing and making sure that you're understanding the other words within that definition. The first thing I want to point out is we've covered this many times, but what I discovered is most of us don't know what this stuff means. Well, then the new definition can't make any sense if you don't know the other words in it. What's a rational expression? Anybody? Elena, you know? No? McKenna, do you remember?
Does that mean it can be written as a fraction?
Yes, okay.
Oh.
So, a rational expression is just a fancy mathematical term for it can be written as a fraction. Now it has letters in it, instead of just like 1/2 or something. But you guys, so if you don't know what a rational expression is, this definition makes no sense. So when you're reading, and I have told you before you start your homework, you should read your notes. But when you read your notes, you should go through and write other things that pop in your head about things you heard me say, or things you now understand after the lesson. And you should be filling in more stuff than what we literally wrote down. If you're only filling in blanks, that's not sufficient, okay? And I'm trying to help you for college, okay? When you go from high school to college, that's one of the best things you can do in a college course is as soon as you have available time after that course was over, read your notes and fill in things that, you're trying to do your best to keep up with the professor, and there were other things he or she said, and now you can remember those. All right, so a rational expression, i.e. a fraction, is in simplest form if its numerator and denominator, okay, I know what numerator and denominator are, if you need to put top and bottom, have no common factors other than plus or minus 1. Okay? Now, I put a note here, just in case you don't see that. This is for you. Yes, I'm using the highlighter tool. It says, note, you may cancel common factors, but not terms. This is so important. But what does that mean? Factors are separated by multiplication or division. And so I could have 2x over 8. So 2 and the x are factors, and so I can cancel 2 and 8. Now terms are separated by the addition or subtraction sign. So if I have x plus 8 over 2, I cannot cancel the 8 and the 2 because this 8 is a term. Now the 2 is a factor because it's by itself, but this 8 is a term. So I cannot emphasize this note enough. You may cancel common factors, but not terms. And I will ask you repeatedly during the lesson today to make sure we have that down. Okay, so a rational expression or a fraction is in simplest form if its numerator and denominator have no common factors other than positive or negative 1. So I can cancel common factors, but not terms. So if I want to simplify a rational expression, step 1, factor the numerator and denominator if possible. Step 2, cancel the common factors. So if you remember, your homework assignment today was all factoring. I did not assign you factoring for busy work. I assigned it because we're going to factor in the next 3 sections. And I needed to verify you guys could factor and factor well. So in example 1, I'm going to factor my numerator and my denominator. And I hope that I don't frustrate anybody because I can factor really fast. So I factor the numerator into x minus 5, x plus 3. The denominator is x minus 3, x plus 3. Now I want you to notice the x plus 3's are factors because it's x plus 3 times something. If I look inside, the x alone is a term and the 3 alone is a term, but the x plus 3 is a factor. So this is x minus 5 over x minus 3. Now, can I cancel the x's because there's an x in the top and the bottom? No, why not? They're terms. You cannot cancel terms, but I cannot tell you the number of students who want to cancel them. All right. Example 2. Let's factor that numerator. That is a perfect square trinomial. X minus 4, x minus 4. Denominator factors into x plus 6, x minus 4. One of the pairs of x minus 4 cancels. So I get x minus 4 over x plus 6. How about the 4 and the 6? Can I reduce those? No, why not? They're terms. You cannot cancel terms. All right, example 3. This one was nice. I already factored for you. So the x plus 1 cancels. And I get 2 over x plus 3. All right, in example 4, when it says to factor, what is step 1 in factoring? GCF. What's the GCF in the numerator? 20. So that's 2x plus 1. What's the GCF in the denominator? 10. Okay, now I can reduce the 20 and the 10, but that's only going to reduce to a 2, right? A 2 over 1 or just a 2. You can leave the numerator factored or you can multiply it out. It doesn't matter. I'd leave it factored. Why do the extra work? Because you might make a mistake, you know? All right, in example 5, what can you do there?
Distribute the x.
Okay, x squared plus 2x, but then what? Like if I do some forward thinking, I could multiply that out, but
Did you reduce because they're not terms there?
Where could I reduce?
The 2 and the 4.
Can you not do anything?
Okay, now Henry, this 2 is not a factor though.
Oh, okay.
You see that x plus 2, that 2 is a term. Yeah, this is already simplified, so you don't say no solution. I hope nobody will do that, because it's not an equation. Don't put an empty set symbol or something, because that suggests you thought we had an equation. All right, example 6. The reason why I chose this one is I'll see a common mistake that students make, and I'm trying to head this off at the pass so we don't do that, is you factor the denominator. That's a difference of 2 perfect squares. My x plus 4 cancels, but I'll see students who say the final answer is x minus 4. And that's not true because x minus 4 is in the denominator. What's in the numerator? What's in the top?
1.
Good job. It's a 1, so don't make that mistake. Okay, now, example 7. I need to, right now I can't cancel them because the numerator and denominator are not identical, okay? However, what we're going to discover is this does reduce somehow. And I'm hoping in Algebra 1 you did this, but let me go through the steps. I'm going to treat it as if you've never done it. The first thing I'm going to do is I'm going to take my numerator and I'm going to use the commutative property and just switch the order. That's the only thing I've done. I just switched the order. I left the denominator alone. The next thing I'm going to do is I'm going to actually factor out a negative sign. And what I want you to notice, when I factored out the negative, it did flip this from a plus x to a minus x. Do you understand why? Negative times 5 is negative 5. Negative times negative x is a plus x. Now look, I do have 5 minus x over 5 minus x, but it reduces to negative 1. So I need you to write a note because this is actually something we can use in general. If you have a minus b over b minus a, this will always reduce to negative 1. Okay? This will always reduce to negative 1. So now we're going to use this in example 8. In the numerator, this factors into x plus 3, x minus 2. In the denominator, do not reorder them because that's a negative in front of the x squared and we don't want a negative in the front. So watch what I'm going to do. I'm going to put the x in the back where it goes. Now this is probably a 5 and a 2. And how much you want to guess? I need this to cancel to -1, so let's give it a whirl. Now what's going to end up happening is, and I'm going to show you this in example 9, sometimes one factorization is easier than another. And so what I do, and it doesn't matter if it's numerator or denominator, if there's one I look at and I'm like, yeah, I know how to factor that, and the other one's tricky, like over here, this one's going to be tricky, I can use what's in the one location and make a guess, because there's a 99% chance it's going to cancel something. So you can sort of, go in the back door with this, but you have to check it. You don't just make it up. You do guess, and then you check it. So 5 times 2 is 10. The outer is minus 5x plus 2x. That's a minus 3x, and x times minus x, so that does work. So my x minus 2, 2 minus x is going to reduce to -1. Be careful, because that's a negative in front of the entire x plus 3. And then in my denominator, it doesn't matter if you do 5 plus x or x plus 5. It can go either way. Now, something that's wrong, and I want to go ahead and write it down just in case somebody just did it on their paper and thinks it's okay. You can't do this. You can't say negative x plus 3. You guys see that? That is not equal. This has to be negative x minus 3. That would work. Alright, now let me show you the shortcut thing, or the, kind of the, it's not really cheating, but it is using your answers to work backwards. My numerator has a GCF. My denominator is difficult to do with trial and error. So my guess would be I probably have an x plus 5. And then let's just build the rest of it. To get 3x squared would be a 3x. To get a 5, this has to be a 1. They're both pluses. Now you just don't move forward from here. You have to check it. We just made a guess. 3x times x is 3x squared. The outer's 15x plus 1x is 16x. 1 times 5 is 5. So then I do get 2x over 3x plus 1. Now, can I cancel the x's here? Can I cancel those? No, because in the denominator, that x is a term. In the numerator, that x is a factor, but it has to be a factor in both places. All right, we are going to do this example tomorrow, because I just need to make sure we can get through all of the lesson. All right, so far what we've done is we have simplified rational expressions. Factor the numerator and denominator, cancel the common factors. Now we're going to extend this to multiplication of rational expressions, and this is still very, very simple. Step 1, factor each numerator and denominator if possible. Step 2, cancel common factors. All right, do you notice there's no factoring here? So what I can do is I'm going to multiply the numerators, and I'm going to multiply the denominators. So I'm getting 56 x to the 7 y to the 4th over 8x y cubed, and I'm using all my exponent properties. Now I want to cancel any common factors. Well, 8 goes into 56 7 times. X to the 7 over x to the 1st is x to the 6th. Y to the 4th over y cubed is y. That's it.
Oh, the G on our paper should be a multiplication.
Yeah, there's no G, I'm sorry. Yeah, my other class said it just is a software glitch. Yeah, those are all time signed. Now, in example 12, I'm going to show you something you can do if it's just, one fraction times one fraction and they're not sums and differences. I could do this. I could say 5 goes into 5 one time, 5 goes into 15 3 times, 3 goes into 27 9 times, 3 goes into 3 once, 3 goes into 9 3 times. You can reduce your numbers first so that this is 3x to the 7 y cubed over x to the 5th, y to the 5th. Do you see that? If it would reduce your numbers first, you can do that. So this is 3x squared over y squared. In example 13, though, now we do have some factoring involved. In the top numerator here on the left, there's a GCF of 3x, so that's 1 minus x. In the denominator, that's x plus 5, x minus 1. This is x plus 5, x minus 4 over 3x. So when possible, you want to factor your numerators, factor your denominators. My x plus 5 cancels, my 3x cancels, and what can you do with 1 minus x over x minus 1? It's just negative 1, so it's a negative times x minus 4. You can leave it like that, or you could distribute. It doesn't matter. All right, try example 14 on your own. Factor each numerator and denominator, then cancel common factors. While you're doing that, let me just mention that tonight you're doing 8.4 homework in your book. It's that first row on the assignment sheet. But if you remember, and I hope you didn't throw this away, on the back of the 8.3 worksheet was the 8.4 worksheet. Okay, so make sure, and I told you when I passed it out to keep that. So that's going to be tomorrow night's homework. Alright, for example 14, did you guys get negative 5? Yes. Alright, in example 15, do not forget about the difference of two perfect cubes. This is SOAP, x minus 3, x squared plus 3x plus 9. Well, guess what? That's going to end up canceling the x squared plus 3x plus 9, and I hope you know that x squared plus 3x plus 9 does not factor. So that's just x plus 2 over x minus 3. Can I cancel the x's? No, they're terms. I cannot cancel those. All right, any questions up to this point? So we simplified rational expressions by factoring and canceling common factors. Multiplication, you just factor, cancel, and you multiply out what's left. The last thing we're going to do is dividing rational expressions. All right, it says rewrite the division problem as multiplication by the reciprocal of the divisor. You know, your notes could actually be of no good to you if you don't know what it means. So we've got to go back through and say, all right, I know division is multiplication, but what's reciprocal mean? You flip it. And what's divisor mean?
The thing you're dividing by.
Okay, it's the thing you're dividing by. And so I really want to encourage you. You could go back to 8.1, 8.2, and 8.3. Go back through your notes and write things out for yourself. Okay? Because my words are what makes sense to me, but your words might very well be different. You might need clarification. Alright, so the first thing you do is you rewrite the division problem as multiplication by, you flip the fraction and multiply by what you're dividing by. So step 2, then it becomes a multiplication problem, which is not a big deal. So let's look at example 16. This is going to go 7x over 2x minus 10. I'm going to change it to multiply by the reciprocal. So I'm going to flip it, the thing I'm dividing by. Now it's a multiplication problem. And in multiplication, you factor each numerator and denominator, if possible, and cancel. Now here's a case where if I look at x squared minus 11x plus 30, that one's really not terrible to factor, but that denominator is way easier. So my guess is there's either an x minus 6 or an x minus 5 above, and it's awfully convenient, it actually has both. But check your work when you factor. So the x minus 5 cancels, the x minus 6 cancels. I have 7x over 2x. Those x's are factors, so I can cancel them. Sorry. Oh my, the possessed board that I have. That's 7 over 2. Alright, try example 17 and 18 on your own. I'll give you a head start. Change the problem to multiplication by the reciprocal of the divisor. Then factor, cancel, see what you can do. And once you do get the hang of this, I do multitask on my division problems. I start factoring and I flip the same step. Okay, you are allowed to do that. Alright, so my x minus 4 cancels, my x minus 2. I get 4x over 5x. If you are comfortable, you can cancel the x's. I just have some students who get bothered when it's written this way. They don't know how to cancel it, so it's okay to leave it in a multiplication form and then do it. Okay, alright, so this one, don't let it bother you. This is really like 3x squared plus 5x over 1. So when I multiply by the reciprocal. And now, here's the case I was referring to. You don't always have to start factoring in the first position. What I'm going to do is there's a GCF of x. So I'll bet you anything there's a 3x plus 5 up here, so I can kind of use information to help me. So I get a 3x plus 5, but you do need to check it. This would have to be 3x times 2x to give me 6x squared. Now I need a minus 15. Now check it. 3x times 2x is 6x squared. Minus 9x plus 10x is 1x. 5 times minus 3, that worked. So I get 2x minus 3 over 4x cubed. Can I cancel the 2 and the 4? No, because in the numerator, it's a term.